Sorry about that. I reply again. So good morning, everybody. Good morning, our noble keynote speaker today, Professor Tatsuya Oshima from Miyazaki University, Japan, and Dr. Muhammad Rafi from IPB University in West Java. Thank you very much for your present today, for your coming to attend this seminar, and then for present your knowledge. And for the attendees, please welcome our keynote speaker today, Tatsuya Oshima, Professor Tatsuya Oshima, Dr. Muhammad Rafi, and later Professor Andri Dian Nugraha. Now we are, for the first time, we will have the presentation from Professor Tatsuya Oshima from Miyazaki. Before that, I have to let you know the background, yes, of him. So can I share your CV first, Professor Oshima? Could you stop share, please? Before, okay, thank you. Thank you very much. So, Professor Oshima is have a qualification or graduated in Kyushu University from Bachelor in Kyushu University, Japan, 1997, and finished his PhD in field of technology in Kyushu as the same university in 2001. So as you see here, the academic career now become a professor in Department of Applied Chemistry in Faculty of Engineering, University of Miyazaki in 2004 to 2018 as an associate professor at the same university and research associate at the same university. Oh no, Department of Applied Chemistry, Faculty of Science and Engineering in Saga University, Japan. And that's from 2001 to 2004. And research fellow, this research fellow, Japan Society for Promotion of Science, GSPS, from 1990 to 2001. And then, yeah, as you see before there, the study. And then doing research, you can see there are 125 original papers already published, okay, from him, absolutely in international journal, you can see here. And then he has also got the award from Japan Association of Solvent Extraction Incentive Award in 2018 about research on new solvent extraction system based on the development of extraction and diluents. And also in 2008, he got the SGAG award from Outstanding Younger Research about the development of extraction separation system for protein by protein surface recognition using calixarene derivative. And then got the grand research, you can see, and teaching. Yes, teaching and research is in the University of Miyazaki. You can see here. And then the member of some professional societies, especially in chemistry, both in Japan. See, oh, Japan, almost Japan. Okay. And then that's all from Mr. Oshima for us to know. And then now the time for you to share what's your presentation. The time is yours.
Can you see the slide? Okay.
Yes.
Okay, thank you. Thank you. First, thank you very much, Professor Selsa, for kind introduction, and good morning, ladies and gentlemen. First of all, I'd like to thank the organizing committee for inviting me this seminar. After the pandemic, I didn't have so much opportunity for the international communication friendship. Therefore, I'm worried about the presentation speaking in English, but I'll do my best for this seminar. First, before my presentation for my research, I'd like to introduce our hometown, Miyazaki. Miyazaki Prefecture is located in the southeastern corner. I'm going to show the pointer here. This is a place in the Kyushu Island. This local place has various natural products such as fish or shrimp or vegetables. If you can visit our Miyazaki City, you can enjoy some local cuisine. I hope in future you can visit Miyazaki or Kyushu Island. I'm working in the University of Miyazaki. University of Miyazaki is one of the natural university in Japan, and University of Miyazaki consists of 5 faculties: education, medicine, engineering, and agriculture, and regional innovation. I'm working in the faculty of engineering. We also have the doctor course, and a number of Indonesian students has already graduated our doctor course. Today, I'd like to talk about our latest study on the solvent extraction of gold on the basis of the ion solvation system. Now I'd like to start my presentation for our research. At first, I'd like to talk about the background of the objective of our research. Purification of gold is an important topic for the recycling for electronic devices, because such kinds of the devices contains much quantity of the gold. About over 300 tons of gold is used annually in the electronic components in the world, and the electric waste of electrical and electronic equipment is recognized as an important secondary resource of gold. By the way, the Tokyo Olympic Games ended last month, you might know winning medal of the Tokyo Olympic Games were manufactured from gold, silver, and bronze, which were recycled from waste electronic devices such as cell phones. This photograph shows obtained from the website of the medal project in the Tokyo Olympic Games. Use cell phone. This means the scheme of the recycle of gold from the electronic devices. Used cell phone were collected at the store, and after the sorting by hands and dismantling, the organic materials was combusted, and after the leaching of the inorganic materials using the strong acid, gold is dissolved in the very high concentration of the hydrochloric acid. This flow chart is the most popular refining process for the precious metals in the hydrochloric acid media. Gold is separated at the relatively early stage by the solvent extraction process. Yeah, this shows molecular structure of the extractant to pick up, to extract the trivalent gold present as HAuCl4, tetrachloroauric acid, present in the high concentration of hydrochloric acid. Oxygen-containing organic solvents such as ethers or ketones are known to extract the organic phase, the gold, trivalent gold, into the organic phase. These two molecules are most popular molecule to extract the gold. Dibutyl carbitol is a triacer compound. This is the most popular extractant for gold, for trivalent gold in the world. They show the good extractability for gold, but this is the most popular extractant. However, this has also small disadvantages. I mean that this DBC has slightly soluble in water, 3 grams per liter. This means the solvent is leaked into the aqueous phase after the continuous operation. Also, the DBC has a relatively high viscosity. It is suggesting that not easy to operate. This methyl is isobutyl ketone, MIBK, is also known the popular solvent, popular extractant for gold. This was a higher extractability compared with dibutyl carbitol, very high extractability. However, the this solvent is not applicable in some countries because the flash point of MIBK is low. This suggesting that it is not easy to operate safely. Can you hear me? Okay. I'll continue my presentation.
Yeah, please.
No problem. Okay.
Yeah, no problem so far.
Okay, thank you. And MIBK is higher solubility in water. This means 19 gram per liter. This compound it can easily leak into the aqueous phase. They are the more popular solvents to extract the gold in industrially. However, they have some disadvantages as shown this slide. Therefore, recently we are conducting the research to find the better solvent for the extractants. They show the better properties compared with the commercial extractants. At first, I'd like to talk about the first trial CPME. CPME is a cyclopentyl methyl ester. This is a very simple structure, and this CPME was commercially available by the production by Xeon Corporation Japan. They can produce they can produce this CPME in 1,000 ton scale. This solvent has some advantages such as relatively hydrophobic. I mean, the CPME is not miscible in the water, and the CPME is stable under the acidic and basic conditions. Now, as shown previously, the ethyl compounds can extract the gold into the aqueous phase, but therefore I examined the solvent extraction of gold using this CPME. Now I'd like to show the video solvent extraction gold using CPME. You can see the flask and the solution of the color of solution is yellow. This means the containing the gold as tetrachloroic acid. Now I'd like to move the video. Sorry, some noisy. Now I'm pouring this CPME transparent organic solution. Can you see video? After shaking, the extraction proceeds very quick. The extraction based on ion solubilization is very quick, and after the shaking about some moments, you can see the extraction of gold into the organic phase. You can confirm the CPME is available for the extraction into the organic phase. This is a typical extraction profile using the some solvents. Vertical axis is percentage of extraction, and the horizontal axis is concentration of the hydrochloric acid. As trivalent gold is present as tetrachloric acid, the extraction percentage depends on the concentration of the hydrochloric acid in the aqueous phase, and the extraction increases with the increase of hydrochloric acid solution, hydrochloric acid. As shown, you can see the MIBK, methyl isobutyl ketone, shows the highest extractability. And ethyl compounds CPME and dibutyl carbitol also shows the extractability under higher hydrochloric acid concentration. This figure shows the extraction capacity for each solvent. The vertical axis is the concentration of gold after extracted into the organic phase. Commercial requirement, industrial requirement should be exceed the 30 gram per liter into the organic phase. Gold should be extracted to higher concentration to the 30 gram per liter. These solvents, MIBK, DBC, and CPME, all three solvents shows higher capacity, more than 30 gram per liter. We examined this. We introduced CPME as an extractant for gold. CPME can load at least 60 gram per liter, as shown this point. We confirmed the CPME was available the extractant for gold with higher capacity. However, we confirmed that CPME is not available in industrial operation because the problem is the physical property. Aqueous solubility of water, aqueous solubility of CPME is 11 gram per liter, suggesting that CPME can leak into the aqueous phase. It is not favorable. And the CPME has also the lower flash point. This means it is difficult to use safely in the industrial operation. So we found to find another candidate to extract the gold. Now I'd like to introduce a different example, the aromatic ethers. This shows molecular structures of aromatic ethers used in our study. Aromatic diester that has two ethyl oxygen were prepared, and some of them were synthesized in our laboratory. We also examined the extraction test using aromatic monoether as a reference. Solvent extraction test is very simple. The aqueous solution was prepared containing the gold and hydrochloric acid, and solvent was used directly without dilution. After shaking just 1 hour, the percentage of extraction was calculated. This figure shows the extraction profile using the aromatic ethers. White diamond keys shows commercial extractant DBC. And one of the aromatic diester, 1,2-dimethylbenzene, shows similar extractability compared with the dibutyl carbitol commercially available extractants. We also examined the different solvents for the extraction. We've confirmed the shorter aliphatic side chains, the higher extractability for gold. I mean, the longer side chains, the aromatic ethers with longer aromatic chains is not available for the extraction. This figure shows the relationship to the extraction percentage in 5 molar hydrochloric acid, and horizontal axis is log p value. This is hydrophobic hydrophilic balance index. We confirmed that aromatic monoethers this blue triangle. Sorry. Blue keys was aromatic monoacids. Aromatic monoacid does not extract gold. And on the other hand, aromatic diester was available for the extraction gold and relatively hydrophilic. I mean, the smaller log P value is available for the extraction of gold. I mean, the extraction of gold is for the extraction of gold, hydrophobic hydrophilic balance is for the solvent is important, and relatively hydrophilic solvent is good for the gold extraction. But the too hydrophilic solvent is not available for the solvent extraction because too hydrophilic solvent can leak into the aqueous phase. This is extraction metal selectivity using aromatic acers. Blue bars is result using commercial extraction DBC. Red bar means result using 1,2-dimethoxybenzene aromatic ether. These solvents show the similar extractability, but the extraction selectivity to gold over the iron and gallium is higher using selectivity is higher using the aromatic diester. Additionally, I examined the experiments using the aliphatic ketones, different various materials. This shows the structures of aliphatic ketones used in our study. They has one carbonyl group and different lengths of aliphatic chains. This is the extraction profile using the aliphatic ketones. Extraction increases with the increase of hydrochloric acid, and the result is similar to that of the using the aromatic ethers. I mean, the ketones with shorter aliphatic chains shows the higher extractability. 2-octanone shows the highest extractability. In contrast, 2-dodecanone shows the lowest extractability. This figure shows the extraction selectivity for the different metal ions using the 2-nonano. We confirmed the 2-nonano is one of the good candidates for the extraction of gold. 2-nonano shows the selectively extracted gold over the various metal ions. But iron, trivalent iron and gallium is also extracted under higher concentration of hydrochloric acid. This selectivity is common for the solvents using the ethyl compounds and ketone compounds. After the extraction, the gold can be recovered quantitatively using the reductive reaction using oxalic acid. This equation shows a reduction reaction after the extracted using organic solvent. This figure shows the XRD pattern of the gold after recovered from the 2-nonano. We confirm the metallic gold is recovered as a resulting material, and you can see this photographs gold is recovered as solid material as metallic gold. We have developed some solvent as an extractant for gold and one to the diester and aliphatic keton was available for the extraction. On the other hand, the physical property is also important for the industrial operation. We would like to emphasize the ACAS solubility and flash point. ACAS solubility should be smaller because due to suppress the leak of the solvent into the organic phase, ACAS phase, sorry. 2 nanonanon shows lower ACAS solubility compared with the most popular extractant DBC. Additionally, the flash point is more than 70 degrees centigrade. This is acceptable for the industrial operation. Now we confirm that 2 nanonanon is one of the most powerful candidate to apply in the industrial process for the solvent extraction used for gold. Now I'd like to show the different opinion to find the solvent extraction. In order to understand the structural requirements for the extraction, we examined the analysis using Hansen solubility parameters. Hansen solubility parameter consists of the 3 intermolecular binding forces, namely dispersion interaction, polar interaction, and hydrogen bonding interaction. On the basis of the classical like dissolves like rule, solvents that show the similar Hansen parameter to the solute would be a good solvents. Now, in this study, Hansen parameter was used as an index to estimate to find the extraction for gold. Namely, we defined solvents which shows more than 50% extraction for gold was defined as valid for the gold extraction. On the other hand, solvents which shows less than 50% extraction were defined as invalid for the gold extraction. After the extraction test, we categorized some solvent for the extraction. As shown this table, 9 solvents were defined as valid for the gold extraction. On the other hand, the 16 solvents were defined as invalid for the gold extraction. This figure shows a Hansen solubility sphere to predict the gold extraction. Solvent which has a Hansen parameter inside the sphere. This sphere, but it means valid for the gold extraction. On the other hand, the solvent which has a Hansen parameter outside the sphere, it means invalid for the gold extraction. We could obtain the Hansen sphere, but however, this Hansen sphere is not complete because solvent that has a larger delta H and delta P is not present in the figure. Therefore, we don't know whether this sphere is accurate or not. Therefore, we added the additional solvents. I mean, they are hydrophilic organic solvents with ACAS solubility more than 100 grams per liter. I mean, this solvent is not available for the solvent extraction operation. we choose these 25 solvent invalid for the extraction process. This shows a revised Hansen sphere. The spheres was obtained more accurately like this by adding the Hansen parameters of the water soluble solvents. Hansen sphere, Hansen parameter of the most solvent can inside the sphere is can extract the gold, and Hansen parameters outside in the sphere is not invalid for the extraction process or cannot extract the gold. But there's small exceptions for this sphere. Acetyl acetone and anisole is cannot available for the extraction, but inside the sphere. On the other hand, 1,2-dimethylbenzene can extract the gold, but slightly outside in the sphere. This result means that this analysis using the Hansen sphere is available but not complete. Now I'd like to show our perspective. Now we are examining the development of solvent for the extraction of gold by machine learning. This is briefly speaking. As shown this my presentation, the solvent for the gold extraction must satisfy the high extractability for gold and as well as a sufficient physical property for metal processing. However, the number of solvent can be the candidate for the gold extraction. We must do so much extraction test, but the resources is limited. So now we are introducing the machine learning to search gold extractant. Objective variable is gold extractability, and the extraplanetary variable is descriptors obtained from the structure of solvents, such as the number of oxygen atom, molecular mass, or hydrophobic balance, and number of parameters would be the explanatory variables. Now I'm trying to develop the program for accurate estimation for gold extraction, and the study is now under the way. I think the time has come. I'd like to end my presentation. Conclusion is shown here, but I'm sorry, but after my presentation, I must leave this seminar. If you have questions, you can contact me directly by email or something. So now I'd like to end my presentation. Thank you for listening. Terima kasih. Thank you very much.
Terima kasih. Arigato gozaimasu. Terima kasih. Thank you very much for Professor Oshima for delivering your presentation and very interesting things, how to extract gold from electronic devices for using to galvanize things, some like medals in Olympic 2020. So the Professor Oshima present how to extract. There are two extraction method using. There are three actually, but two is good. And then how they find more extractant, and then also how to optimize the extraction, and then the end with the machine learning to how to also optimize the extraction. So that's very good presentation, Professor Aoshima, and then thank you very much.
Professor, I received some questions. I have a meeting from 10 o'clock. I'll try
sure.
reply by typing these questions until the 10 a.m. Thank you for the questions.
We will send you by email the question we got today or already on. Yeah, so you can free to leave if you want.
Okay. I'll try and reply them some questions by text until the 10 o'clock.
Yeah.
Thank you very much.
Yeah. And then have a nice time.
Thank you very much. I'm very glad to have a communication with you.
Yes, we will continue to contact you with our people in Faculty of Mathematics, Tadulako University. Yes,
I hope so. Thank you very much. Okay, I'll end my slide. Wait a moment.
Okay, while you stop your presentation, the next presentation actually, and then the same condition with Professor Oshima, that very busy today, and then we will have the next presentation from Professor Andri Dianugraha from ITB. Hello, good morning. Selamat pagi.
Good morning, selamat pagi. Good morning, everyone. Ohayo gozaimasu.
Very busy today.
Not really.
Yes. So sorry about the time, but yes, we will let you to your presentation. But let me first introduce you to our audience. So let me first moment, please. Yes, I will let you know about Professor. Sorry, not this one. Yeah, should be this one. Okay, Professor Dr. Insinyur Andri Dianugraha, Bachelor in Science, Master in Science, was born in Ciamis, 8 September 1978, and is working now in the Global Geophysics Research Group in the Faculty of Mining and Petroleum Engineering, Institute Technology of Bandung in Bandung, West Java. So as you can see here, he graduated from the bachelor in ITB, as well with the master degree in different area, actually seismology, geophysics, and then and he graduated his PhD from Kyoto University in seismology. Yes, and he got the Doctor of Science. Then position at the moment is Director of Non-Regular Education of Institute Technology Bandung from 2020 to now. Yeah. So publication, you can see his by checking this ID, Scopus ID, and then you can see the index now is 14, where September 7, yes, so recently. And then you can show and shares the publication there, so you can see here. And then you can also found him on SINTA, the Indonesian index for publication and so on. Yes, so the index 21087. And then you can see he's the member of Indonesian Association Geophysics, I think the head at the moment. And then also American Geophysics Physical Union, and then Asia Oceania Geoscience Society. So I think that's all from him to know about our keynote speaker. So to know directly give the time to you because I your visit today, and then yeah. So thank you. The time is yours.
Okay, thank you Pak Elisa. Thank you Ibu Dekan, Bu Darmawati. Thank you Pak Nengah. He's my friend when I was in Kyoto University at the time, and all committee in Tadulako University. May I share my slide first?
Yes, please.
Okay. Could you see my slide?
Yes.
Okay.
Yeah.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Good morning. Ohayo gozaimasu. Today, I would like to talk about a different topic, actually. First of all, thank you very much for inviting me to give a presentation at the third International Seminar on Science and Technology organized by Tadulako University. Actually, in 2019, or 3 years ago, I visited Tadulako University. Thank you, I met Pak Elisa, Pak Nengah, and all my friends in Tadulako University. Okay, this is the title. Actually, let me introduce myself. My name is Andri Dianugraha. I am from Geophysical Engineering, Faculty of Mining and Petroleum Engineering, ITB. I would like to talk about the seismic structure around the active fault study case for the 2018 Lombok, Indonesia earthquake from temporary seismograph network. Actually, this is our team, our partner from BMKG Indonesia, from PPMBG Indonesia, and also from EOS NTU Singapore. This is the outline. What I would like to talk in this morning. First, I would like to talk the introduction, and the second, the seismograph temporary deployment around Lombok, Indonesia, and the third, the hypocenter or even identification of the recording of the seismogram, and then hypocenter determination, and then the travel time tomography, and the attenuation tomography. Actually, very different topic. This is what we conducted at the time. In the 2018, we conducted seismograph installation or field survey in Lombok for recording the aftershock of the 2018 Lombok earthquake. At that time, we collaborate with the EOS NTU Singapore, Dr. Wei, BMKG Indonesia, Dr. Muzli, PPMBG Indonesia, Mr. Afif, and from ITB, the person in charge in the field at the time is Pak Dr. Zulfakrija and teams. Actually, this is the National Seismic Hazard Map of Indonesia, published in 2017 for whole of part of Indonesia region. Actually, not only for the Lombok area, but also actually for the Sulawesi area, actually. But in this morning, I would like to talk about the Lombok earthquake 2018. Now, actually, we can see here, this is the National Seismic Hazard Map around the Lombok area here. So there are several sources of the active fault here, including the subduction zone in the southern part related to plate motion between Indo-Australian plate, subduct beneath the Eurasian plate here. And the northern part of the Lombok, there is a back arc thrust fault that we call Flores back arc thrust. We can see here as indicated by the red line here, and also the strike slip fault between Lombok and Bali, and strike slip fault between Lombok and Sumbawa here. So in 2018, July 28th, the first main shock, the first event occurred in northern part of Lombok with the magnitude of the 6.4 at the time. And then several days after the first event, we from ITB collaborate with our partner from BMKG and so on, go to the field to install the seismograph at the time. So from Bandung, we directly go to the Lombok at the time and install some seismograph at the time. From the August of the 2nd at the time, I remember. And then in August 5, the event, the significant event, the strong event occur again with the magnitude of 7. And then several weeks later, there were also a strong event at 19 August, 2 events at the time with the magnitude 6.3 and magnitude 6.9. And we can see here, this is the color cycle here. This is the event and the aftershock event that recorded with our temporary seismograph that we installed at that time. And this is the beach ball that we call, this is the focal mechanism type. Yeah, this is the truss type or reverse type here. So this is the projection of the hypocenter along the longitude, and this is the projection along the latitude. We can see here something like this. And then this is the situation of the seismograph deployment around the source region of the 2018 Lombok earthquake. And we can see here, and this is the reverse blue triangle indicate for the temporary seismograph at the time that we install. And this is our team. This is Pak Zulfakrija, Pak Yayan here during the installation of the seismograph in the field at the time. So we observe the event or the aftershock from the period of the August 3 to September 9, 2018. And the number of station around 13 to 21 unit at the time. And of course, this is the collaboration between ITB, YOS, NTU Singapore, BMKG, and PPMBG at that time. This is the seismogram or the waveform, for example, for the one of the event that recording from our temporary seismograph at the time. We can see here, this is from, for example, this is station 1, station 2, 3, and so on from the 3 component seismogram. And this is the red line for V ripple time and the blue line for the S ripple time. This is, we conducted actually for the picking of P and S ripple time manually by eyes. Of course, take time. Of course, need hard work to see the event, to see the waveform one by one by eye. Actually, and this is that we call the Wadati diagram, and this is the P rifle, and this is the S rifle, and we already we detected the number of aftershock during the time period here, about 3,259. And then we have been successfully fixed the P rifle around 28,000 and S rifle around 29,000 respectively. And this is the ratio PPO per VS around 1.71. Actually, this is average, yeah, close to the average of the global PPO VS around 1.73. And then after we identify the event and then picking of P and S rifle time, and then we determine the hypocenter location. Yeah, this is the determination of the initial hypocenter location using that we call a nonlinear method. And of course, we need also the initial 1D seismic velocity model from AK135. And this is the seismicity concentrated in the northern coast of the Lombok around here, and is clustered into region 20 to 40 kilometers across. And then we interpreted this presumably represent the seismogenic sediment length for this section of the Flores Back Actras. Yeah, Flores Back Actras is around here. And in the depth, actually we can see here, and this is the projection of the hypocenter into depth. This is along the longitude, and this is along the latitude, and we can see here the cluster of the event. The most seismicity is located shallower than 20 kilometers, which is the depth of the 4 main shock captured by the local network. Yeah, we can see here. So, and this is the type of the event for the strong event, for the significant event, almost similar type. This is the reverse or thrust fault here, with the striking west to the east, for example. And then after we already determined the initial hypocenter location of the earthquake, we enhance the location of the hypocenter through the hypocenter relocation determination. So in our field, in seismology, in geophysics, the hypocenter are further refined using the common technique in seismology that we call the double different method, implemented in the HypoDD program. And of course, again, we need 1D seismic velocity model that was updated by using Veles method at the time. And actually, we can see here, and this is the relocated of the event. Yeah, we can see here, this is for the segment 1, yeah, indicated by dashed black line. This is segment 2, and this is the segment 3. And also we observe also something like a few of the event here, or this is a seismic zone. Actually, we need to more investigate it. We need more to discuss about this. And the temporal and spatial clustering of the seismicity suggests that the Flores Oceanic crust, yeah, that we call FOC to the north of Lombok is segmented. Yeah, that I mentioned. Yeah, this is look like segmented, something like this. And the large earthquake to be generated by the movement, yeah, between the Flores Oceanic crust, subducting plate, and operating the island of Lombok. Then the event related to the subduction system of the Flores Oceanic crust beneath Lombok with a back arc thrusting mechanism. And this is the initial location of the hypocenter, yeah, for the vertical cross section from the north to the south, yeah, and this is the back arc thrust around here, and this is the distribution of hypocenter and the main shock around here, and this is the Rinjani volcano around here, and this is the hypocenter relocated. Yeah, we can see here, and our interpretation, we can see here. Maybe this is something like the fault here from the back atlas, and maybe there is a sub-parallel fault around here. And then we conducted the travel time tomography actually to see the subsurface seismic structure looks like, and to see how the geometry underneath. And the objective of the travel time tomography is to determine P-wave velocity structure, PP, S-wave velocity structure, VS, and ratio PPPS structure around the 2018 Lombok earthquake region. And we use the Simul VS12, yeah, to simultaneously invert for our travel time data for earthquake, hypocenter, 3D PPVS, and PPPS ratio structure. And we can see here the tectonic setting of the study area in the Sunda subduction zone. And we use 20 seismic station for the tomographic inversion. And for the parameterization of model, we set up the horizontal section, yeah, grid spacing 10 by 10 kilometer as indicated by black pluses here. And we can see here the reverse blue triangle for the seismograph temporary that we install. and the average vertical grid spacing is around 10 kilometers. We can see here. And of course, we evaluate the resolution for all space model by using checkerboard resolution test, derivative wake sum, and the diagonal resolution element that we can see here. And this is the vertical cross section from A to L action here, yeah, for the checkerboard recovery of PP, yeah, we can see here 1 and 3 column, and for the ratio PPPS for the 2 and 4 column here. And actually, this is the recovery of the checkerboard test to see how well we can interpret the result. Yeah, the synthetic travel time data are calculated through the synthetic model of alternating positive and negative seismic velocity anomalies. For example, here we put plus minus 15% relative to the initial 1D model, 10 kilometers across, and the synthetic data set is then inverted using the same parameters as the real data set. Gaussian noise is added, yeah, to the synthetic data. Actually, this is fairly good, yeah, to see the recovery of the checkerboard test by using our temporary seismograph network and the data and also the coverage here. And this is the tomographic inversion result. Yeah, actually, this is the vertical cross section from A to A accent, from south to the north, and to F to F accent. Yeah, here we can see here. This is for the PP structure for the first column, and the second column for the VS structure, and the third column for the PP upper VS ratio structure. Here, blue and red color indicate for the high and low PP VS, and actually for VP upper VS ratio, vice versa. And then we can see here there is a white cycle indicate for the hypocenter location. And we can hear there are the symbol of R1 and R2 indicate for the interest option that we want to interpret. Actually, this is the region or R1. Yeah, for example, this is for PP and VS and ratio PPPS. Yeah, for VV, we can see low PP, low VS, and also moderate to high PP/PPS ratio, extend from west to the east, yeah, along the North Lombok coast and coincide with the aftershock cluster, which define the rupture fault, yeah, southward diving and parallel to Flores Back Actras. And this is the R2 actually, R2 here, low VV, low VS, and also a high PP upper VS is farther to the south beneath Rinjani here, Rinjani volcanic complex, and little seismicity and gently deep to the southeast. And then this is another, the others actually vertical cross section, yeah, from Z accent to L accent. Yeah, actually this is GG from the south to the north, and L accent from the west to the east. We can see here. This is from region 3 or R3 here. You can see here. This is R3, for example. We observe high PP and high VS, and also low PP over VS. Yeah, we interpreted it, collocated with a larger cluster of earthquake to the east, Rinjani volcanic complex. And then we observe another interesting feature is region 4 or R4. We can see here R4, low VV, low VS, and high PP over VS with the north-south striking. And then we observe also another feature, interesting feature, R5. Yeah, we can see here R5. Yeah, we can see, wait, right. Okay, R5 here, actually low PP, low VS, and high PPPS, and also little seismicity, extreme from west to the east on the certain part of the cross-section line. And actually, this is our schematic diagram for the interpretation. Yeah, actually, this is from the previous study from Professor Sudirwiyantoro, and this is from our result. Yeah, actually, this result already published in Geophysical Journal of International. The PP structure from the regional tomography, yeah, like this, show the subducted Indo-Australian plate, as indicated by blue color here, beneath the Lombok and the short diving of the lithosphere directly north of the Lombok. And then in this study, we zoom in around here, yeah, beneath Lombok, and we can see here. This is from our study, the 2D interpretation for the crash beneath northern Lombok based on PP model along the section of the A accent, where the Flores oceanic crust represented by a gray block, yeah, something like this, that's subducted southward, and we can see here this is something like a pier, a weak zone, coincide with the region 1 or R1, located in the middle of this block. Yeah, our presentation, our interpretation, maybe this is depression of the weak zone, probably the result of pervasive fracturing and presence of hydrous fluid from above and below the Flores oceanic crust. And below, this is the 3D cartoon of the southward subducted Flores oceanic crust. Yeah, blue is high velocity, red is low velocity, represented by blue block, something like this. This is the 3D cartoon actually, 3D model. And red color zone stand for the weak zone, marked as region 1 in every single north-south where the most of aftershock occur in this zone. Actually, this is the cartoon of the geometry of the Flores oceanic crust derived from tomographic inversion from our study. And then we extend our study to determine another physical parameter, something like the attenuation, or that we call 1/Q. Yeah, the seismic attenuation tomography. The objective is to determine a 3D seismic attenuation structure around the aftershock, the south region of the 2018 Lombok earthquake, Indonesia. We use the station around the similar station, actually 13 station from August 4 to September 9, 2018. And this is the horizontal grid spacing 10 by 10 kilometer. And this is the average vertical spacing 10 kilometer. And this is the data that we use for the seismic attenuation tomography. Yeah, this is the blue, this is the black flash here for the parameterization model. And this is the cycle with the different color for the epicenter location. And then for the attenuation tomography, first we have to determining the T-star parameter that we call the attenuation operator. So we can see here the attenuation structure can be estimated based on the amplitude decay of seismic wave, which can be quantified through the T-star parameter. Yeah, actually, assuming lambda is 2 and Q is frequency independent, the observed amplitude spectra can be written something like this. Yeah, actually there are 3 parameters need to be determined. First is the common frequency that we call corner frequency, and then low level spectra that we call omega 0, and then T star that we call operator attenuation. And we can see here, this is the example how to determine the 3 parameter. For example, this is around the P wave arrival time. This is the length of time we know around the 2 seconds, and then we take the fast Fourier transform, yeah, to determine the waveform spectra. And then we can see here, there is the black line is the observed spectra, and the blue line is the model spectra, and here is gray line for the noise level. Yeah, actually, and then the spectral fitting is applied here. Yeah, to get the T star, to get the omega 0, and also corner frequency. we can see here. This is actually this is a good example to see how well the observed and model spectra is fit. And then after we already determine the T star, we use the value as input for the attenuation tomography. Yeah, actually the relationship between the attenuation operator T star, quality factor Q, and velocity P can be expressed in the following equation, something like this. And then we apply the SIMO PS 2000 to obtain the 3D frequency independent QP structure from T star value. So in this study, we just determine the QP structure or attenuation of P-web structure. And the initial QP was 300. So, and the initial 3D PP velocity from travel time tomography that I mentioned earlier. And we can see here, and this is the vertical cross section that I will show later for A to A accent, B, C, and D, passing through the Lombok, and the reverse blue triangle here for the seismograph station, and the red pluses here for the parameterization model for the attenuation tomography. And this is the ray path in the area. We can see here, this is projection for the horizontal, this is along longitude, and this is along the latitude. And of course, for the tomographic, we evaluate the resolution by using several type. For example, this is for diagonal resolution element, and this is for derivative exam, and this is for ray heat cone. And black and white color indicate for the high and low value for DRE, DWS, and for the RH here. Black is actually for the good resolution, relatively. And then this is the attenuation tomographic inversion result. And this is for the cross-section A, B, C, D. And this is for PP, and this is for PPPS ratio, and this is for QP, or 1 for attenuation here. And for QP here, blue and red color indicate for the high and low value respectively. And we can see here there are some interesting feature actually. For example, R1, R2, and R3 here. And we compare our Q structure or attenuation structure with the PP structure derived from the travel time tomography. And we can see here, this is the schematic diagram around the Lombok Island here. We can see here the inverted triangle marks the surface of the fault location from Irsam et al. And the yellow star denote the magnitude 7 August 5, 2018 Lombok earthquake, which has a thrusting fault mechanism from the global CMT catalog. And the white dot here indicate the location of the hypercenter with a radius of 3 kilometers from the center line. And the red line here indicate the fault from Supendi et al. And the black line here indicate the fault from the Yang et al. And the green area near the red file indicate the high temperature fluid content. And the dark blue sediment here layers represent the upper Miocene limestone. And the green sediment layer represent the Pliocene to present young sediment, and the light blue layer represent the oceanic. Actually, that all that we had, and the same method actually can be applied for the Palu Koro fault. Actually, I have also one student from Tadulako University. Now he is he has been studying about the travel time tomography for the Palu Koro segment fault. Yeah, thank you very much. Ya, thank you, and terima kasih. Saya kembalikan ke Pak Elisa.
Thank you very much. Terima kasih, Prof. Andri. So as you asked, we want to directly going to the Q&A. So Pak Muhammad Rafi, so this is not plenary. The speaker talk, and then at the last we are doing a Q&A. but today is quite different. So sorry about that. And then Prof. Andri, yes, as you asked, we will going directly to the question. So people want to ask question to Prof. Andri, please write on Q&A, and we can asking all you. Okay, yes, that's a good the top.
Actually, the question also can be sent by email to me. It's okay, actually.
Okay, yes, yes.
Okay.
So there is a question already in the Q&A for you.
Yeah.
So thanks for the nice presentation. I want to ask about the pace identification. How your team get more number of S pace or then P pace? Thank you. So this is from Muhammad Fauzi.
Okay, I know him. How are you,
Okay.
Fauzi, from Hasanuddin University? So actually, commonly, the number of V larger than S space actually. I don't know in our here, so I will check first. Sorry, please wait. Actually, this is small mistake actually. It should be P larger than S space. Thank you.
I see. So
It should be, yeah, that's true.
That's correction.
Yeah, okay, thank you. Commonly, P space is larger than S space. That's right. Thank you, Fauji.
Okay. So, any question? If you want to directly asking, maybe we can have the time. We still have time, Professor Andri?
Yeah, of course.
Yeah, okay.
Thank you, Pak Elisa.
Okay. If the attendees want to directly, I can give you the chance to asking. And then you can talk to Professor Andri. Raise your hand if you want to directly speak to our keynote speaker today.
So that is actually in the chat room from Muhammad Yudhistira Aziz from ITB.
Done. Yeah, yes.
Ini from ITB, the same with me.
Yeah.
Actually, Pak Elisa, maybe from ITB also attend the meeting, Pak Elisa.
Okay. Yeah.
Okay, actually, for this method, as far as I know, this is have not been applied for the early warning system. This is just for the, for example, for the travel time tomography, yeah, for the something like the seismic structure determination. Actually, for early warning system, maybe using the similar method, but the application, of course, different, because for early warning system, maybe need to accurate and need to faster to issue to the community. Maybe for the method similar, but for the application, of course, different. Yeah. Okay. Any question from?
Question? Yeah. So if the attendees, because attendees we can't see the attendees, but I can see here from the list the attendees. If you all raise your hand, you want to directly asking, I can give you the chance to do that.
Yeah, actually, now we have been conducting the seismograph temporary deployment around the Lembang Fault, Sesar Lembang, northern part of Bandung, from the 2019 November up to present. Actually, we install around more than 14 unit, actually.
So,
and yeah,
okay. Continue first.
Actually, maybe we need to collaborate with other universities and institutions, to conduct the similar study. Actually, maybe for the future, maybe you can collaborate with Pak Elisa, with the Tadulako University, to conduct the seismic survey. Maybe let's yeah, we hope the pandemic will be finished soon, so we can go to the field.
Yeah, that's right. So this is a kind of interesting research to do as well in Sulawesi, especially in the central Sulawesi with the Palu Koro Pole, and then at the surrounded area.
Okay, ini, there is also question also from Muhammad Yudhistira Ajis. Yeah, so actually for this method, we determine the seismic structure, the geometry, for example, in the source region of the Lombok. Yeah, so which one which one the Flores oceanic crust, which one the weak zone, and so on. Gitu, yeah. Actually, for the movement of the land, maybe from the GPS and geodesy study is much appropriate.
I see.
Yeah, for our research, just to see the structure, the seismic structure, not for the movement.
So actually the answer is from the question from Muhammad Yudhistira Asis, that your method can reach until what deep to identify the movement of the land or etc. So so that's the
Okay.
answer already. You already answered. Yeah?
There is question from Parusli. Parusli is my friend. How are you, Parusli? How about Palu earthquake when Prof. Andri research in Palu? Actually, there is now PhD or doctor student from BMKG. Now he is conducting the seismic structure around the Sulawesi, Makassar Strait, and Kalimantan Island. And let's see, and actually maybe this year or the beginning next year, he will try to publish the result, Parusli. So from our student, from BMKG actually, he is from BMKG. Yeah, okay. Maybe in the beginning next year, we will try to publish the result. Thank you, Pak Rusli. Yeah, nice to meet you.
Actually, yes. Any question, please, from the audience? I give you the opportunity to directly to ask if you want. So I asking Professor Andri that you have limited time today but please let us know when time. But we have the time also to about your.
Yeah, actually, the question can be sent to my email. Yeah. Thank you very much for attention, Pak.
Yeah. So, Pak Yudhistira still have a question.
Okay. The equipment. Actually, we buy actually the instrument. Yeah, of course, from the abroad. Yeah. For example, ITB itself, we have some instrument, and then we collaborate with another institution that they have also the same instrument, and then of course we go to the field together. So we coordination, we collaborate, to install the seismograph. Actually, the equipment still from abroad. Actually, we buy actually. Now actually we have been trying to develop the seismograph instrumentation. We hope maybe in the near future we can make itself. Actually now in prototype. Yeah, actually it's okay. We can see here maybe in the future we try.
Okay. Any question to Professor Andri?
Okay, thank you.
I see there are more questions. So thank you very much, Prof. Andri, for delivering your.
You're welcome.
Yes, it's an interesting thing to know the structure of the seismic activity because of the seismic activity, especially in the fault like Lombok and in this area as well in Palu, Sulawesi, Central Sulawesi. Yeah, thank you very much again.
So,
And yes,
I have to leave because I
Yeah.
have a class.
Yeah.
I'm sorry. Thank you very much, Pak
Yes.
Elisa, Pak Nengah. He is my senior in Kyoto University, and Ibu Dekan, Pak Raffi dari IPB, Pak Saban dan panitia. Terima kasih semua. Thank you very much. Ya, sehat selalu. Mangga. Assalamualaikum warahmatullahi wabarakatuh. Ya.
Waalaikumsalam warahmatullahi wabarakatuh. Sampai ketemu, Prof.
Ya, mangga.
Arigato gozaimasu, Prof. Andri. Dan selanjutnya kita akan melangkah. Thank you very much. And then we next going to, sorry about that. Going to the next plenary. We continue our plenary session with our last keynote speaker from Dr. Raffi. But I have to say sorry to Dr. Raffi, but because the way to deliver our plenary session is not as in the schedule, but hopefully you understand the situation. Okay, thank you very much, Dr. Raffi. And then before Dr. Raffi present his presentation to us, let me introduce first him to you. So Dr. Raffi, or Dr. Muhammad Raffi, is born in Bekasi, March the 16th, 1977. Now is working in Department of Chemistry, Faculty of Mathematics and Natural Science, IPB University in Indonesia. And then also in Tropical Biopharmaca Research Center, IPB University, Indonesia. So you can see here the email, and then he graduated his bachelor in IPB, as well his master degree, and he graduated his doctoral PhD in Gifu University. It seems like this is Korea or Japan. Japan. Okay, thank you. So mostly from Japan now today.
Yeah.
So his doctoral is in chemistry, chromatography, and chemometrics for natural products analysis. So, and then research activity from today is he has more research, you can see here. And then publication, almost 2000 in this year. There are already more, and you can see this year, and then last year as well. So mostly every year I can see here about 5 to 10 publication each year. And then the book already published or made, as you can see, there are 2 books already, and then actually published in 2017. And then now he the president of the Indonesian Chemical Society. So for the people in the part of chemistry know him. So maybe some of you didn't know the president of the Indonesian Chemical Society. So Professor Raffi is them. And then also the member of Chromatographic Society of Japan, Metabolic Society, and HPTLC Association. I don't know a little bit, but maybe the C is chemistry. And then the Indonesian Association of Natural Drugs and Researchers. So that's the membership of him. So now to save the time, I directly to give you the time for you, Dr. Raffi, to present yours. Please.
Yeah. Okay, thank you very much for nice introductions. Elisa Sesa, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, good morning everyone. I would like to thank to the organizing committee for inviting me join in this very nice symposium. Yang saya hormati Ibu Dekan, kemudian Pak Menah, dan everyone. So let me share my screen. So my talk will be not a little bit. It's very different from Professor Andre and also from Oshima Sensei. Yeah, I would like to talk more about natural product research, especially applications of metabolomics in the natural product research. As mentioned by Pak Sesa, I come from Department of Chemistry, also from Tropical Biopharmaca Research Center and Advanced Research Laboratory, IPB University. So, as already give information by Pak Sesa, now I'm senior lecturer at the Department of Chemistry, Faculty of Mathematics and Natural Sciences, IPB University. And also I serve as the head of master and doctoral degree program in chemistry, also editor-in-chief of Journal JAMA Indonesia and PIC of Metabolab Advanced Research Laboratory, and also now still serve as the president of the Indonesian Chemical Society. And my primary research interest is in the field of metabolomics and chemometrics, especially for the development of quality control methods, because my background is analytical chemistry, and also identifying biomarker compound and standardizations of medicinal food plants. And this is my email if you would like to contact me regarding anything. So I don't know this is coincidence or not, because the speaker is come from Japan alumni. All. Yeah.
It's very good.
Okay.
The sound is clear.
Yeah. Okay, this is some example by using metabolomics for our research in the standardizations of Androcrappis paniculata, Sambiloto in Indonesia, when we use many instrumentations for evaluations the quality of Androcrappis paniculata raw material. So something like this we develop in our research. And this is some publications with my students, especially from master and doctoral degree. This is my latest, our latest publication regarding using metabolomics or chemometrics in the field of medicinal plants from Indonesia. Number 4 is we use Curculigo species, most come from the Sulawesi Island. Yeah, as you know, IPB University has 6 campuses. So this is one of the agriculture university in Indonesia, and we have 6 campus, and main campus is this campus IPB Darmaga, and this is our department of chemistry. We have 3 degree programs, bachelor degree, master, and doctoral degree, and already accredited, especially for bachelor degree, accredited Unggul. Master degree is A. Doctoral degree we have to submit now for the full accreditations. So this is what I will be talk is about what is metabolomics, and then related to the natural product research, and also an example of metabolomics applications in natural product research. So what is metabolomics? Before we know about metabolomics, we have to know about the omics science overview. So omics science, genomics, transcriptomics, proteomics, and metabolomics. Metabolomics is closely related to the functions and phenotype. So this is an illustration of the flow from genes to metabolites to know the functions and the phenotype of plants, animal, and so on. the interactions between the ohms and the omics technique used to measure them. So metabolome or metabolomics usually related to the small molecule, usually it's organic compounds. So what is metabolomics? Metabolomics is systematic identifications and also quantifications of the small molecule metabolic products. We call it metabolome of a biological system, cell, tissue, organ, biological fluid, or organism at a specific point in time. If you would like to know the differences between solvent extraction used for some of organic compound, or you would like to evaluations in the 2, 3, 4 month post planting, the differentiations of the secondary metabolite or primary metabolite presence in the plants in a specific time. And we know that nothing new in metabolomics. We do metabolomics study in before, because just different directions and also combinations of the present technology, metabolomics becomes now hot topics in the biodiversity and also pharmaceutical, and also for the plant or animal analysis. Because in metabolomics, we evaluate or we analyze using many sophisticated instrumentations, so we can get more comprehensive or holistic interpretations of the differentiations present from the metabolites. So metabolomics is about quantify everything, but quantify everything is still a dream by chemists, biological, and also lab sciences. So quantify everything means we have to detect, we have to identify all the compounds, but still very limited. So because of that, some approach we can use in the metabolomic study. Before that, we have to know in this metabolomic study, what should we know about some knowledgement from the chemistry, especially analytical chemistry, because we have to know about the sample preparations and also data acquisition, because it will with the data analysis is very important. So we should to make the detections components become more reliable, and also as much as possible we can detect the components. And also, so the knowledge of analytical methods is very important in the metabolomics, because if we would like to analyze the plants, sometimes we have to optimize the methods, because plants is comprise more than 100 of compounds, and every plant it will be different, the compositions and also the concentrations of the components or metabolites. After that, we have to analyze with the chemometrics. Chemometrics is using statistical analysis in the chemistry data. So by using this one, we can interpret the results more comprehensive and holistic, because we can relate it the signal or the compositions and correlation and concentration of each metabolite with something like biological activity of the plants. And also by using biological knowledge, we can identify the compounds and also identify the functions, phenotype, and so on. So this is the three corners in the metabolomics. We have to know analytical methods, instrumentations, data analysis, usually we call it chemometrics, and biological knowledge. So it's like a triangle in the metabolomic study. So in the metabolomics strategy, metabolomics is ideally we can define as unbiased identifications of all metabolite in sample. But I say like before that, this is like yeah, I don't know, maybe more than a decade, 2 decades later, we can do this identification. But now, because we still don't have any instrumentation to detect and also to identify all metabolites, so mostly everyone is used this 3 approach in metabolomics, namely targeted analysis. We analyze the specific or non-compounds, like we analyze gingerol in the Zingiber officinale or ginger. Or we can use metabolite fingerprinting. In metabolite fingerprinting, there is no obligations. We know about the structure of the components. And in metabolic profiling, usually we quantify or identify in the specific metabolites pathway. Like we provide the phenolics. So maybe we can provide flavonoids and also phenolic acids and so on. And this is some workflow in the metabolomics. Usually come from molecular hypothesis formulations, something like there is a different chemical compositions in the 2, 3, 4 months post-planting of some plants. And then we design the experimental designs. And then we can select, we would like to target it or non-targeted. Non-targeted is like using the fingerprinting and providing approach. And also we have to optimize the sample preparations because as we know, every plant animal have different compositions. So the methods is very specific. So we have to optimize the methods. After that, we analyze the sample with the instrumentation also in this step. We should also do optimize the conditions of the instrumental technique that we use. You know, after that, after we can get the signal of the components, so we pre-process and also analyze the data by using the multivariate analysis. So we can get like discriminations or classifications, or we can correlate with biological activity. So after that, we can have new biomarkers, pathway analysis, and also anything related to the components and also its functions. So metabolomics is now many applications, many fields use metabolomics because I'm from IPB related to the agriculture. Mostly our research is do with the agriculture and some with the pharmaceutical, usually using the medicinal plants. But now I'm also support the in the wood identifications, especially using the Makassar ebony. I will be giving some data that we identify the geographical origins of the Makassar ebony. And needs in metabolomic study is how to extract all metabolites. So because metabolites is very important to get some informations. So if we didn't extract all, extract the maximums of the metabolites, we cannot get many useful informations. And after that, we have to separate, we have to detect the metabolites by using some analytical technique like chromatography or spectroscopy. After that, because we have huge data, we can reduce to obtain from analytical detections that related to the clustering or something. that we intended use. And then how to extract hidden informations, yeah, from the analytical data, from the raw data. Sometimes we have to pre-process or pre-treat the data because as we know that if we analyze with instrumental or instrumentations, we sometimes suffer with the noise, or we have to calculate like signal to noise ratio. So differences or discriminations is not related to the signal from the noise. Because of that, we have to pre-process and also pre-treat the data. So after that, we can identify maybe the functions of the metabolites, or they can cluster it because of these metabolites. So after that, we can get more information related to the functions of the sample or the metabolites present in the samples. In the research of in the natural product research, as we know that in Indonesia, we know that we still many our people use like traditional medicines in Java known as jamu, maybe. But as we can know, raw material or after extraction or fractionations, and also get some pure chemical components now, like Taxol and Blastis is come from also from the natural products. Raw material, extract, fractions, and then isolate chemicals is very important in the natural product research. So sometimes from the raw material or extract or fractions, we can find the pure compounds that exhibit some biological activity, like Taxol and Blastin is as the anti-cancer. This is some I found from the Seoul National University about Natural Product Research Institute, how they can do some research in the field of natural product research, from the how they can use natural product informatics, I think like bioinformatics or cheminformatics. So, and then they also do some like cultivations, botanical identifications, also doing natural product chemistry, like standard extract or fractionations, and also structure determinations or elucidations, and also screening for the biological activity. This is some example how we do some natural product research activity in maybe our institution or something. In Tropical Biopharmaca Research Center, we add some economic value for the jamu or Indonesian traditional medicine as part of our from downstream to upstream research in the Tropical Biopharmaca Research Center. And then in organic chemistry, usually when they would like to isolate compounds with particular biological activity, they use isolation, extractions, isolations with some chromatography technique, and screen by the bioassays, and also do bioassay direct fractionations and also isolations. After that, they can get some pure compound and then elucidate the structures of the compounds. But now metabolomics play in the other approach by using we can do extraction with different solvents polarizations. We can get some difference or different concentrations and also compositions. And after that, by using the statistical analysis, we can correlate the bioassay result and with the signal from the some instrumentations and do like a statistical analysis, we can identify the biomarkers, and also we can validate by isolate these identified biomarkers if the identified biomarkers is still unknown, if we can check by using the NMR or the mass spectrometry. And this is some example how some researcher identify of active compound from Annona crassifolia extract as anti-larvicidal of Aedes aegypti. So they use like this one, they extract with hexane, ethylastate, methanol, and then by using the metabolomics approach, they analyze with the instrumental technique. This is like LC-MS, and then test all the fractions with Aedes aegypti, and then do like some multivariate analysis and also networking analysis, so they can get some predicted components. The predicted components, they isolate and also they check with the bioactivity and can found that in the bioactivity guided approach via metabolomics approach, they can know that acetogenin, annonacin, and squamosine is this anti-larvicidal for Aedes aegypti. So metabolomics approach is a shortcut for the long, tedious, laborious isolations of chemical components in this natural product research to predict the biomarkers or novel compounds exhibit some biological activity. So that one is some like examples in the natural product research. I will talk more to the medicinal plants because I'm in the Tropical Biopharmaca Research Center, mostly do like medicinal plant studies. So as we can know, the chemical components is related to the biological activity, and when the compositions and also concentrations is fluctuative and didn't know exactly all of the components in total, so the biological activity will become more fluctuative because chemical components is affected by the environmental growth, cultivations, and also harvest and post-harvest and genetic variety, something like that. So the differences in the chemical components will affect the biological activity. As we can see here, this is some example. We collected some Andrographis paniculata from different regions, and after we run in the thin layer chromatography, we can see here that the spot or the band is very different in color. So it means the concentrations is different, even in the different regions and also in the plant parts of the samples. So because of that, we have to process from the from the medicinal plants until the finished product. We have to standardize to complete to fulfill the main issue in the herbal medicinal products development, like efficacy, quality, and safety. So we need to standardize the whole process in the beginning of development and production. So we need the standardizations protocol. So we also have to develop some quality control method to obtain that the phytochemical compositions and concentrations is not very different in each batch of productions. So we have to develop a valid analytical method for standardized of raw material and herbal medicinal products for consistency in the biological activity. So the compositions and concentrations is not extremely varied, compositions and concentrations is not extremely varied. We have consistent in the biological activity, and also we can get the standardized herbal medicines. So QC methods, sometimes using the metabolomic approach, usually they commonly use is targeted analysis. Now, sometimes we develop fingerprinting or profiling analysis for the holistic evaluation of the raw material. Usually, We use QC methods for identifications, discrimination, and authentications of some medicinal plants. This is some example about our developed method by using high performance liquid chromatography and coupled with the linear discriminant analysis for the detections, adulterations is orthosipon aristatus or kumis kucing in Indonesia. Kumis kucing is widely used in the many commercial herbal for the antihypertensive or for the antidiuretic. So some related plants like Eupatorium riparium and also Acalypus siamensis is very similar in the leaves morphology. So sometimes we can found or maybe some cheating some cheating producer or something using this two kind of plant because the lack of the Chapati or Orthosipon aristatus raw material. So we have to develop to identify the authenticate of the Orthosipon aristatus or kumis kucing. We develop the methods. This is the optimum conditions that we found. I think the students is I think about 2 months to find these optimum conditions. So we also quantified the rosmarinic acid and also sinantin to the to also check the quantifications of the marker compounds that we found in the Orthosipon aristatus. So by using the HPLC, we can find here the mix of the siamensis with the Orthosipon aristatus or Eupatorium riparium. It will comprise different chromatographic signal or chromatograms. So by using this whole data from the chromatogram and by using the chemometric analysis, we can discriminate the pure Orthosipon aristatus, and this is the mix with the Eupatorium riparium and also mixed with the Acalypus siamensis. If unknown sample is the dot is here, it means that the sample is adulterated, is already adulterated, not the pure of the Orthosipon aristatus. This is some example. After that, we use also by using the spectroscopy analysis, UV-Vis. Also, we can differentiate for curcuma species mostly used in Jamu respi. So how we discriminate this for plants to prevent the substitutions. So by using the UV spectra of the four curcuma species, and this is the data that we measure from the 200 until 800, so we can get like 1,200 data for each sample. So by using the principal component analysis, we can differentiate the curcuma longa and also curcuma sontoriza, but we cannot get differentiation for the curcuma manga, curcuma aeruginosa, because maybe, yes, we can see in the spectrum is very similar. So we need some other multivariate analysis. By using the canonical variate analysis, we can cluster the curcuma manga and curcuma aeruginosa in each group. So we can differentiate the four curcuma species in this study. So by using FTIR also, we can investigate the antioxidant activity and with different location of growth and solvent extractions. This is the FTIR spectra. I think very similar from Bogor and also from Bandung. Not very different. But there is some a little bit differences between the FTIR spectra from Bandung and Bogor, maybe a little bit difference in the compositions or the concentrations of each metabolites present in the sample. But by using the whole data from the FTIR spectra, we can get clustering based on the extractions and also based on the locations. This is from Bandung, this is from Bogor, and we can get clustering for each solvent extraction based on solvent extractions. And we measure the antioxidant activity. We found that from Bogor is more active than from Bandung, and ethanol 50% is the best solvent extraction. And after we correlate with the FTER spectra, we found that the OH group, C double bond C, and also C with O, representing the phenolic compounds, is a functional group from the antioxidant compound that gave major contributions in the antioxidant activity by using the partial least square regressions method to correlate the FTER spectra and also for the antioxidant activity. If we use like mass spectrometry based instrumentation, we can get what chemicals that give the major contributions for the antioxidant or any biological activity that we measure to know the biomarkers or the how the metabolites contribute to the some biological activity that we measure. And this is some other applications in the wood identifications. As we know that wood identifications, we can use also wood chemistry for the compositions, analyzing for the compositions and also for the concentrations. We do chemical profiling by using LC-MS to detect and to cluster the geographical origins by using the UHPLC QRB trap high resolution mass spectrometry. And we use ebony as the wood. So we collect ebony from 3 provinces in Celebes, from Central Sulawesi also, in South Sulawesi and West Sulawesi. And then we preparation the dust of the woods and also the extractions, and also come to the sample analysis. And this is some result for using OPLS DA for the clustering of the ebony wood. And we know that there is about 35 metabolites identified based on an in-house databases in ebony sample used in the study, mainly from the quinone group, like diospyroxide, diosindigo, habibone, and so on. And by using all of the data from the chromatograms, we can cluster ebony from 3 provinces: Central Sulawesi, West Sulawesi, and South Sulawesi. And we can get the information from the diploid analysis. Diomylquinone is identified as a marker compound from ebony from West Sulawesi. Maybe diomylquinone is more higher in the West Sulawesi compared to the other. 3-methylpomblagin and camphorol were markers for South Sulawesi. So by using this marker, maybe we can trace, we can check the geographical origins of the ebony, because ebony is already in the as the danger plants, yeah, and now still have the still illegal logging for ebony is still happen, so we have to prevent that from the illegal logging. So in summary, metabolomics is a versatile approach in the natural product research, and also can use in many applied science field. And also for the future trends will be used data fusions from the 2 instrumental analysis, like FTIR with the LC-MS or something like that. So I would like to thank to our groups, analytical chemistry divisions in IPB University. We have 3 main research groups: metabolomics and chemometrics, natural product analytical chemistry, sensor and material for analytical chemistry. Also, I would like to thanks for the Professor Ichiro Fukusaki from Osaka University, Sastia Pramaputri, Osaka University, Iskandar Z. Siregar from IPB University, and also Bu Eti Rohaiti from IPB University, and also our collaborators from different university from outside and also from the Indonesia. And we still open for the collaboration with other university. Thank you very much, Dr. Sesa. I'm
Thank you
finished
very
with
much,
my
Dr.
talk.
Rafi, for a nice presentation and interesting, because most of the attendees must be from chemistry. So should be there is a question about this question. So before we going to the Q&A, let me conclude. This is I just doing this because the two our two keynote speaker before they are really rushing to go, so I didn't do that. So metabolomics is widely used as a comprehensive approach in natural products research by identified or systematical qualified of small molecules metabolites resulting from metabolism of a biological system. So it's play a crucial role when studying phenotypes or change in metabolites due to the treatment given to an organism. Also in metabolomics, knowledge of biology, this is very important, biology, biochemistry, instrumentation, and analytical methods, and data mining, or what we call chemometrics, are necessary. It's very useful to interpret the research results, to obtain the accurate result. And then currently metabolomics approach widely used in the research of natural products from upstream, like in agriculture, such as cultivation, harvesting, post-harvest of raw materials, and to downstreams, like development of herbal, medicinal, herbal food products, and searching for bioactive compounds. Also in development and quality control of method finished products like a food, herbal, and products. So that's about the presentation today. So if you have a question to this presentation, please write your question directly to Q&A, or we can give you a chance to talk directly to Professor Dr. Ravi about the topic we are talking today. So there are already one question here, and then maybe you directly can see there, Dr. Rafi.
Yeah, I can see.
Okay. So
okay, from Ibu Nurhaini, is it only the compositions or nutritions of nutrient to determine the level of fruit maturity in metabolomics research, or is there a compositional analysis standard that must be used? Fruit maturity. Yeah, I think it will be difference when we check what metabolite contribute for the maturity. I know that a researcher from Osaka University, I don't know if she already gave some talk in the Tadulako University, because her husband is I think lecturer in the Tadulako University. She now in Osaka University, mainly her research is due in the fruit maturity by using the metabolomics approach. Her name is Sastia Pramaputri. From her results, I can see that many metabolites is changes during the fruit maturity. like for example, from mangosteen, pineapples, there is many different chemicals affected the fruit maturity, not only in the compositions of nutritions. So we have to check all the metabolites that can be that we can detect or we can identify with some instrumental analysis. So I think different fruit will be have different chemical compositions, so will be different contributions in the fruit maturity. Nothing like that, Pak Sesa?
There are question also in the from chat room from
Yes.
Nismayanti from Nismayanti. So what kind of device you use in this research, maybe? Yeah, to the research.
I'm using what we have.
Yeah. So what?
So
what you have?
we have like the like UV spectroscopy. I think all of the laboratory in Indonesia have the UV spectroscopy. This is the cheapest one, like UV spectroscopy, FTIR, and also we have the liquid chromatography and gas chromatography, and also now we have UHPLC, Q Orbitrap, high resolution mass spectrometry. And now we dealing with buying for some GC QTOF MS for our totalomics development in the metabolomics research in IPB University. So mostly using the chromatography and also spectroscopy.
Okay. So that's the answer. So there again, there is a question from Muhammad Yudhistira Aziz. Can you see the in Q&A?
Yeah, Pak Judis. Yes. Yeah, my friends. Pak Yudis, can we apply the metabolomic system in environmental pollutant in environment by fingerprinting or profiling? Do you have any suggestions? The type of chemometrics quantitative analysis, which simply can elaborate some the data analysis. It will depend of your goals or your purpose to detect, only to detect, or only to evaluate whole the environmental conditions. So if you would like to only detect some potent or some danger pollutant, you can use targeted. But if you would like to evaluate all the environmental conditions, you can use fingerprinting or profiling. And chemometrics quantitative analysis you can get by using the multivariate calibrations, like we sometimes use partial least square regressions to quantify the pollutant. Or if you would like to check the environmental conditions, you can use like discriminant analysis or other supervised technique to like to evaluate or to know if in these conditions there is differences between in the upper surface or in the down area of the environment that you measure for the environmental pollutant. So I think chemometrics and metabolomics now many some environmental scientists use that kind of approach. Now I'm also support the National University of Singapore. We do now collaboration research in the pit metabolomics, pit swamp. So we check the organic compound and also for the inorganic analysis. Sometimes in organic there is some term metallomics. So we quantify whole of the metals in the samples.
Thank you very much for the answer, Dr. Rafi. If some of the attendees want to directly speak to ask the question, I can allow you to talk if you want. So not typing, but directly asking rather than type.
Alicia, may I ask one question, please?
Okay, yes, please, Pak Nenga.
Thank you, Lisa. Thank you very much for Dr. Rafi. Presentation is very nice presentation and very interesting talk. I would like to ask about one interesting point to me is about by analyzing the metabolomic data, we could decide from where actually in the plant is growth. For example, from West Sulawesi or North Sulawesi. But I would like to ask you whether you have any evidence or analysis data relating to the genetic rather than to ecological data. How about this issue? Thank you very much, Pak Rafi.
Ya, terima kasih Pak Nenga. For the genetic data, we have the data because like we do with the wood identifications of ebony. Besides, we do some chemical analysis. We also check the DNA barcoding to authenticate the Makassar ebony, and also use some like PCR or something like that with the other groups, because this is collaboration research. So from the anatomy, from the DNA analysis, and also from the chemical analysis, we check it all of the contribution to the wood identifications. But from the chemical analysis, I'm using the multivariate analysis because chemicals is related to the phenotype. Sometimes phenotyping is more difficult compared to the like genomics, transcriptomics, or proteomics. So, but we can also use the multivariate in the proteomics and also from transcriptomics and also from genomics. But in the metabolomics, as you can see that in the PCR analysis of the ebony from 3 different provinces, the compositions is very different. So I think because of the environmental growth, maybe we have to check it also the quality of the environmentals, like the soil, like the environment, and so on. And differences in these chemical compositions is can only affected also by the seasonal variations. If you collect it this year and next year, it will be also different, the chemical compositions, because the plants is like accommodate the difference of the environmental growth. So I think because mostly I do with the chemical analysis, so I'm using the multivariate for the chemicals, but for my other colleagues, using the multivariate for like genomics or transcriptomics, something like that.
Thank you very much.
You're welcome.
Thank you very much. And then it says, Dr. Rafi, actually, if you see the time, the schedule, we are already over the time. Actually, so but we have still time if we want. But if there is no more question, we can finish. Oh, is there any question? Let me see. No. If you want to directly talk, I can allow you to talk. We have a student actually in the attendees, maybe talk about research for students, something like that. And then what the very simple way, maybe, but as you see, yeah, instrumentation using.
Yeah, you can use like UV-Vis or FTIR or thin layer chromatography. It's
I
very
see.
simple.
So biology and chemistry working together here.
With the statistics.
Statistics. Oh yeah,
Also.
that's right. Because for the calculation, analysis, the data. Yeah, right. Because so we have a more. The data
Yeah.
is very huge.
Very huge, yeah,
So
very
then
big.
you have to make like yeah that's happened. The statistics using here. So I think that in biology and chemistry they use statistics for the to analyze the data. Again, if no more questions, so we have to finish our. Oh, there is a question coming from say again from Muhammad Yudhistira Aziz. So chemometric is not interesting in Indonesia. What's your suggestion? Yeah, that's something like.
Yeah. It's not interesting because in our brains, I choose chemist because I don't want to meet the mathematics or the statistics or the computer sciences, something like that usually. But me also first, I'm choosing chemist because I didn't like mathematics in the after I graduate from the high school. But after that, because I'm in the chemistry area, I'm choosing analytical chemistry. Analytical chemistry dealing with the data. Data come from the instrumentals, and yeah, you cannot hide from the mathematics, statistics, or computer sciences. If you get like big data or huge data, so you have to deal with that. So why is chemometrics still not interesting? I don't know, because every year we conduct like workshop for the chemometrics, and mostly many many other researcher or other participants come from to IPB to study the chemometrics. Maybe because they want to have simplicity of the chemometrics.
I see.
Yeah, this is some barrier when we would like to understand something, because if we want only simplicity is become not many understanding that we can get from the information. So with the self-learning, and then with the online lectures or something like that, you can hear some many development in the chemometrics area. So maybe also in your university, the statistics is not very developed one, because in IPB we have Department of Statistics, and many our friends is interested with the chemicals data. Because of that, we can collaborate. So something many models, many applications in the statistics that we can apply in the chemical data analysis. So sometimes we collaborate with the statisticians by we to supervise joint supervisions to our students, and also sometimes supervise the statistic students. So it's I think it's very rare when chemistry students is supervised by the statisticians, or the statisticians is supervised by the chemists. So we have this collaboration is already like a decade. So some with these situations, it's very interesting to us. Many new thing comes when we collaborate with the other fields.
Okay, then that's something like we need together, working together.
Yes. Definitely
That's
yes now.
collaboration. Yes. If no more question, because time is running, and then actually we have to stop at 11 due to the schedule. but few up to half an hour. So we
Sorry.
should stop now at the moment. Before you leave, Dr. Rafi, we have to thank you very much for your presentation. Also with the previous, our keynote speakers, Professor Tatsuya Oshima and then Professor Andri Dianugraha, that we present you our appreciation. We present you in moment, please. We have a certificate for our keynote speaker, especially for the day 2 today. So here I share. So this is a moment. It's very slow computer. Yep. So as well, we will send you the certificate through email.
Thank you.
Yeah, for your participation and your readiness to this. Yep. So this is for our first keynote speaker, Professor Tatsuya Oshima. And then the next is for Professor Dian Andri Nugraha. And then the last is yours for a keynote speaker today in our international seminar on science and technology for the third time in 2021. Thank you very much,
You.
Professor.
Thank you again.
I always say Professor, but that is you will going there.
No problem.
Ravi. And thank you very much.
Thank you.
And also thank you very much for our audience, attendance, guests who attend this international seminar this year. And then don't forget, almost forgot. We will send you the link for the closing ceremony today. So if you're able to come, but please join. So moment, maybe our friend, because my WhatsApp is not working here at the moment. So if any one of you on this can send the link to the chat room for our attendees, so they can come on the closing ceremony of about 6:16 or the 4 p.m. in the afternoon, 4 p.m. So let me share it before we left. So that's very important thing for. Oh no one using it. For waiting, sorry. Moment. If someone have the link. Oh. Looking for the link for the closing session. Oh, sorry. We have to take the picture, take a photo screening by gallery. So if one of, I put some of our participants. Do you still have a time, Dr. Rafi?
Yeah, it's okay. No problem.
Okay. So, yeah, you don't. I can see that you don't have a special request today. So yeah, if you have, so we will let you actually. So it seems you are free. So I put some our guests or attendees today, and then we take the picture. Oh, okay. I think that's okay. If some of Pasafan, are you okay to do take the picture? So if we still have 5 inside. Oh no, yeah, this that's happened that sometimes attendees didn't know that they are asking to go to the panelists, so they didn't ask what to say. Okay, admit. Okay then. So Pak Sapan, take the picture as well, Pak Nengah. Yeah, okay. Could you take the picture? One, smile. 1, 2, 3. Again, 1, 2, 3. That's okay now. Thank you very much. Pak Dr. Rapis, mungkin kita sudah bisa pakai bahasa Indonesia di sini karena kita sudah all Indonesian.
Terima kasih.
Hanya Pak,
Bapak.
mohon pisan. Iya. Nah, ini sudah kami berterima kasih banyak sebagai panitia Bapak telah memberikan waktu dan menerima undangan kami, permintaan kami, permohonan kami untuk menjadi pembicara. Terima kasih banyak Pak Dr. Raffi.
Sami-sami, Pak.
Iya, walaupun memang lewat teman-teman di kimia ya menghubungkan saya sebagai ketua panitia dengan Bapak. Terima kasih sekali lagi. Mungkin Ibu Dekan, do you want to say something to Dr. Raffi?
Yeah, thank you very much for Pak Dr. Raffi. Makasih. Thank you for your nice presentation. We hope we will continue this collaboration to the next activity.
Okay,
Thank you.
you're welcome.
Bu Dekan, mungkin saya kira Pak Nengah ada sesuatu?
Oke, baik. Sudah waktunya istirahat, nanti kita siapkan untuk parallel session.
Okay, that's right.
Ya.
Okay.
Terima kasih sekali Pak Raffi.
Ya,
Sami,
terima kasih,
Pak
Pak
Nengah.
Raffi. Sampai bertemu kalau mungkin kita bisa bertemu directly.
Thank you.
Saat setelah corona.
Insya Allah.
Sorry.
Corona.
Ya, silakan kalau mau keluar nanti kita gabung lagi. Ya.
Sekali lagi
Saya juga
kami
mau
akan
pamit.
mengirim di grup authors untuk hadir dan juga mungkin mahasiswa untuk bisa hadir pada sesi closing nantinya. Terima kasih dan selamat siang.
Selamat siang. Terima kasih Bu Dekan, Pak Nengah, Pak Elisa.
Saya pamit juga ya.
Ya, izin pamit.
Ya. Ya, silakan, Pak.
Selamat pagi.
Waalaikumsalam.
Siang.
Selamat siang.